Cool. So I found this package, right, called commanded, and I was immediately like impressed because as I went through and thought about the problems that I'm facing and that I faced, I was like, okay, well, how does it handle this problem? And I went through and it, boom, there was a explanation. This is how we handle this problem. One thing after another, and it was really exciting for me. So I want to share it. I want to kind of go through it a little bit with you. I went through it a bit yesterday. I couldn't help myself, but let's go through it together and kind of see how it approaches some of these ideas. So it's called Commanded. It's apparently out of this company called Alembic, or at least Alembic is sponsoring it, right? I know Alembic is a company that has the creator of the Ash framework, which is like a domain modeling framework in Elixir. So I think that there's a lot of really cool Elixir stuff going on there. But this package, it's really more of an ecosystem. It's more than one package together. And the idea is that uh, there's this whole world of event sourcing and CQRS that come together to make most of the kind of apps that we would build with these tools, right? We're not just using events and then populating the inside of a model and calling it a day, right? We're doing so much more than that. So let's check this out. So I know they have the an event store implementation for Postgres and then for Greg Young's event store database. So we can look at the event store in a minute, but I want to kind of get started with seeing how you use it. Right. So I don't know if you're familiar with commands. Basically, the idea here is when we have a model, we want to make state changes against it. We want to validate those state changes with some kind of decision-making mechanism. And then we want to have an event come out, and we can use that event either just to fuel the internal of the model or to react to it to do something else, right? So in this is the structure, the struct syntax for Elixir. So this is an open bank account struct, and it has two properties, right? Account number and initial balance. The struct is just a data structure specification. And in Elixir, a data structure is attached to a module. A module is a concept where you can store either a data structure declaration, you can store macro declarations, you can store, I believe, you can store function declarations, right? And basically, modules are uh, not the same as like a class in a class-based language, but it's a unit of cohesion for this kind of stuff, for functions and whatnot. And so here we have an open bank account command, right? So I want to open a bank account with this account number and with an initial balance. Here is an event, bank account opened. Now, when we get to the aggregate, you can see that the aggregate has a few different pieces, right? We have this bank account aggregate, right? And I know you probably know my opinion about bank account as an aggregate, whatever. Let's see how they do it here. Um, and then you have the API where we are executing commands and hopefully making decisions about how valid those commands are, and then triggering the outcome. So in this bank account aggregate, we have the an execute function that takes, and this is like you can think of as an overloaded function. A pattern matches on the results. Here's the state of a bank account, and here is the command. Well, it kind of goes a little bit far past, but so the idea here is that for every time you call execute against the aggregate, you're passing in the state and you're passing in a command. There is a guard clause when initial balance is greater than 0. And if you have a nil account number on a bank account state and you do the open bank account command with an initial balance greater than 0, it will return this event, bank account opened. So you can see here, this is an example of the decision-making model part of an aggregate. We can do the same open bank account command down here in the second example, but if the initial balance is negative, less than or equal to 0, right, we'll return an error instead of an event. Yeah. So that's kind of cool. So we have the state of the aggregate defined as this struct. And this state is just enough state necessary to get from the events such that you can make the guards that you want to later. So we use the account number as a guard to determine if we can open a new account, right? Oh, we already have an account number on this account. We can't open this bank account again, right? It's just enough to make that decision. Let's look at how we mutate this state, though, with each event that's raised. Aren't these rules meant to be defined in the commands? So if these rules were meant to be defined in the command, what we'd have is an open bank account command, and it would have the rules about what is a valid whether or not we can open the bank account, right? So an example of a rule to have in a command is the account number is already nil. If we load all of the events for a bank account and then we apply them to the state and we end up with no specified account number, right? We know that the bank account is not already opened. And so we can go ahead and open this up. It's possible in the command or the command handler, right, to say, I'm going to query to see if this bank account exists. And I'm going to make the decision about whether or not I can open this based on that. But generally speaking, there are a few different ways to look at aggregates, right? I'm in the camp that the aggregate contains the decision making. You put everything into the aggregate you can, right? So in this case, the event stream will build up into this aggregate to construct the state, and we can inside the aggregate decide if we can make the state change. So I would really prefer not to have these rules defined in the commands. I would prefer to have all of these rules for the bank account in one single place. Now that doesn't mean that we can't have validation on the command level, right? And there's difference between things like if you have validation on money. So money can be represented at any level of precision you want to. Money can be just the amount in minor such that you can't go below a single cent in US dollars or euros maybe. But it's a perfectly valid model to use money with fractional cents. So you could pass in something like a money object or a money struct, maybe in this example, that is valid. But then you decide that when opening a bank account, it's not valid just to have any amount of money, right? So we want to make sure that the initial balance is locked in before we make the state change, because the events are the most critical truth of the system. So we want to make sure that the state change that the event represents is locked and limited in one place, so that we don't have the accidental opportunity to open to open the bank account against the rules. And so that's why it's in the aggregate. And ideally, as many decisions are being made in the aggregate as possible. This maybe even includes like a domain service. So if you think in like an object-oriented language, you might have an interface that represents some kind of domain service. Like let's just say we decided we're going to do unique emails with a dedicated component. We inject the interface for that component into the aggregates rule um, of registering a member or something. And then inside the aggregate, we can interact with that interface. That means the decision making and everything is still happening inside the aggregate, right? But we're not doing this thing where we're reaching out from our domain objects into other code, like persistent specific code or something like that. We're locked in and limited at the interface level. So I would say that these are really good examples of rules that we would want in an aggregate. Um, but I've seen people have different perspectives. Sometimes people think of aggregates as just a way to raise an event or something like this. And there's a lot of different thoughts on this, but this is mine. So we can see though when the bank account opened event is applied. So let's say the bank account was already opened and we have stored event in the event store. When this aggregate state gets rebuilt from all of the events for the aggregate, we can say, okay, let's look at the account number and the initial balance in the event. Like, so what we're doing is we are right here. You can see it. This is the match operator, right? Because in Elixir, there is no such thing as like an assignment operator, right? Elixir and Erlang work differently than that. The idea is this match operator says, I want to balance the left side with the right side. And the way it does that is it uses pattern matching to solve, like essentially solve the equation. So in this case, we're saying we expect to match event with a struct of type bank account opened. And then within that struct, we want to match the account number to this variable and the initial balance to this variable. So because those variables don't exist, it'll say, oh, well, how do I balance both those sides? The event that I received and this structure over here with these variables. And it will solve that equation by binding the values within the event to these variables. It's possible, yeah. So I won't go too much more detail into that unless it's particularly interesting. But it's very cool to me that there is not this assignment operator. Everything is done with matching, and the same kind of matching that's happening here is the kind of matching that's being used in the function declarations as well, with really interesting effects. But what's happening here is we basically pull the account number and the initial balance out of the event that we received. And then we take the bank account state. So it's state of this structure type, which we specified up here, right? It's specified right here as part of the bank account module. And the state that it's given, we're calling account. So you can see here, the first argument will be the current state. So if you imagine that there's a bunch of events that are being applied one after another, each of them gets the current state as a bank account structure. And then it's able to do things like right here. What this is syntax is saying is take the account state and then apply this value to this key and this value to this key. So now the balance and the account number are assigned to the values from the event. So that's how this event has been applied to the state. So what ends up happening is when we execute with this framework, with this Elixir event sourcing CQRS framework, when we execute something like an open bank account command, the first execute function clause gets matched only if there is no account number specified and the balance is greater than 0. And that's what we determine is necessary to open this bank account. And then the result of that will just be this event. But if we receive any bank account state and the command, but the initial balance is less than or equal to 0, we get this specific error. Initial balance must be above 0. If we receive, after attempting to match those first two, we go to the next one. If we receive any bank account state and any open bank account event, we say error, the account is already opened. Because at this point in time, we've decided the initial balance is fine, but the account number is not nil. That's what we would have checked in the very first clause. So first, is the account number nil and the balance valid? Cool. Let's open the bank account. And then if it doesn't match that, it matches the next one, then it matches the next one. And this is how we can implement these invariants on a case-by-case basis. So in Elixir, it's really common, same as Erlang, right, to have function clauses that each handle a specific case. So you don't end up with functions that have a lot of like, if this, then that, do this, then that. I mean, you can, but like, you can see how having function clauses that segregate by individual cases can simplify each of those cases so that the functions themselves are very simple. So I think this is a really cool way of creating an aggregate in Elixir. I'm going to try to shrink this down a little bit, maybe. Let me know if there's any visibility problems. Hey, Mateus, Mohammed, and Codito. So I guess, okay, so the way that they dispatch different commands is they define a router, which is cool. They route to the bank account aggregate, and the identity, the account number must be kind of the event stream that they're querying out of the event store. So an event handler module that updates the bank account balance. Okay, so this is an event listener. The event listener does some uh, OTP startup, right? So in Erlang, of course, these processes come in and they just run. They're like concurrent processes. And they open up and they can handle things. In this case, the account balance handler looks like it will handle the bank account opened event. It will extract using pattern matching the initial balance, and then it'll update the state using an agent. An agent is a state agent. It's just a pattern for managing state with the balance, and you can get the current balance here by querying the balance. So that's interesting. It's not a particularly complex example. So this is how it looks. You take the application, which has a slightly different term in Erlang and Elixir world. An application is um, not the entire system, because you got to think about any Erlang application is kind of a distributed system within one unit, right? But within this thing, we have this bank app, and we want to dispatch to it this command, and then we get back okay, right? Pretty cool. Now, when I dug deeper into this, of course, it supports things like snapshots, etc. When I dug deeper into this, I was like pretty impressed about how rich the do we just do this one? Here's register user. How rich like the capabilities of this thing were. So it supports different levels of consistency. So this is what it looks like. We can open account and deposit money, and these route to an aggregate. We saw this previously, but these are handled by these specific handlers. And it's possible, and I saw this earlier, it's possible also to route the command directly into the aggregate itself. So if you don't want a command handler that can do all the business, like this is to me what a command handler looks like. It handles, it will receive from the framework the bank account's current state, and it will receive the command. And then, yeah, you can pass in the state to the bank account aggregate open account method or function, of course, with these properties. So this is like a normal handler, and in these handlers, you might do things like log uh, log the command itself, record metrics about the account opening process, like this specific instance took this long to execute and it was a success. So then you can chart those in like Grafana or Datadog or something. So this is like a normal handler, but you can dispatch also directly to the aggregate, which I think is interesting. I'm hesitant about this because sometimes you'll want more than just the command details that go into the aggregate. You might want like some kind of domain interface or domain service reference to go in there too, so the aggregate can use that for decision making. But it's really cool that this framework allows you to choose which approach. If you find that you want to be able to just directly dispatch a command to an aggregate and have that just work, and have the framework take care of the storage of the event, the dispatching of the event, all of that stuff, then you can do that. And I think I would probably maybe default to that and then see where I didn't need it and only do the other example when necessary. Let's look for something kind of cool here to talk about. This is pretty cool. You can identify aggregates using a prefix. So a lot of times you'll want to make a token that represents an individual identity and not just use a pure UUID approach. So you can have a prefix in here. So when you go and look at your event store, you can see, these streams are all of type bank account or whatever. So that's pretty cool. Of course, you can specify your own way of doing identity. And as with everything like Erlang or Elixir, you can specify timeouts, because the thing about the the working in this paradigm is that it really kind of does decide that all of these little concurrent things are almost like servers themselves, and as they communicate with each other, you want to account for things like what happens on a timeout. And it makes it really explicit. So just baked into the OTP framework and the language, you can say, I want to receive a message and then perform this behavior when I receive a message. But if I have a timeout time of 5 seconds and I don't receive a message, I want to call maybe like a keep alive or a ping or something like that. Or maybe after 30 seconds of not receiving a message, I want to gracefully put myself to sleep, store my state, shut down that process, so that, you know, this process can receive a bunch of messages and do a bunch of stuff. And it's very performant, but after a while, it's like, oh, okay, we're done interacting with this. Let's go to sleep now. So that's pretty cool. Command dispatch consistency guarantee. So this supports strong consistency, which I would call immediate consistency, and eventual consistency, right? So when we talk about CQRS, this is like always one of the big topics. Do I want? Is it okay to have immediately consistent, command dispatch, or I mean, is it okay to have eventually consistent command dispatch? So sometimes you want to dispatch a command, send it in, and you specifically want it to go to a queue or something and get processed asynchronously. Sometimes you want to dispatch a command and only have it return once it is completed. So once it returns, oh, okay, now whatever immediately consistent state changes are made in the system that come out of this, those are made once I get this okay response returned back. So that's really cool. You can choose the consistency level differently. It's just kind of baked into the framework. Very cool. You can make your command dispatch return results. So this is another question people always ask: is it okay if my command bus returns results? And the answer is, it's up to you and your software design in this system. Generally speaking, I think it's okay if you return results from a command bus, but it's not always really needed. I find that mostly I don't need it, but it's cool that this is built in. You can just return a result, and you'll get a bunch of details back. Like this, these are the events that resulted from this process. So if I called bank account open and I get an opened event back, I'll see it here with the metadata of the event, which includes things like the stream ID, stream version, causality, correlation, that kind of thing. Very very nice. And the cool thing about having the framework be this flexible is you can just decide on a case by case basis how much you want to go down one road or another, and your application code doesn't have to be that distinct one way or another. I'm really impressed by this. And I really love that, like, baked into this whole thing is causation and correlation. I took some time over the past couple of weeks to explore what I would want from an event sourcing and CQRS framework for myself. So I dropped down into code and I started writing my own pieces and seeing how they interact. I could interact with the idiom of the language, and I ended up with something that's like remarkably similar to what I'm seeing here. But of course, when I look at this, it's so mature and fleshed out that I personally, this may be the best event sourcing and CQRS framework, at least for my purposes, that I've ever seen. So I can dispatch a command and pass in causation and correlation, right? So like, let's say there's I'm reacting to an event that came in, and that event has a correlation identifier of 5. I might want any command that I dispatch, right, to have the same correlation identifier. So when I go and figure out, oh, what was the entry point into this application, what is that identity, I can look at all of the correlation IDs, all of the messages that come out of the system, whether commands or events, and say, what correlates, and I can see everything that's connected to it. It's like an event related trace. It's pretty special, I think, especially if you get really into how decoupled these systems can be and how nicely you can individually model different features in isolation. Having the ability for tracing and understanding the relationship between events is really cool. Very cool. Yeah. See, here's an example where this is a event handler, right? So it's receiving an event and reacting, and you can see that you get a like a map that comes in with these two values, and you can just use them here. So the events identifier itself is the cause of this command, but whatever the event was correlated to is also the correlation for whatever comes out of this command. So very cool stuff. Hey, what's up? Dota 2 attitude. This is a cool thing too, because again, let's remember that with the Erlang virtual machine, these processes that come up are like certain little mini servers inside the system, highly efficient little servers. And so this is a cool feature. You could say, I want when I interact with this aggregate, I want it to stay awake for an hour or whatever. And if the bank account becomes closed, then shut down the process. Um, and you can kind of give it hints that like keep it from having to reconstruct uh, the process when you expect to get some more interactions with it shortly. I just added CQRS event notifications to my code base. Aggregates are a DDD concept, hard to get the head around, right? I I think that aggregate really just it's about being able to guard state changes. And when we're doing like an event source aggregate, it's about making events that fit the rule set, right? So maybe you can talk a little bit more about the getting your head wrapped around it, right? I think that one of the common thing that people struggle with is the idea that um, you might model an entity in like a non-event sourced way, uh, so that it kind of fits in to a database table relationship. And then with an event source model, you end up having a much wider you end up casting a much wider net where the events themselves are the state, not the reconstituted entity that you maybe reconstituted through Hibernate or some other ORM, but rather the entire model, including the reactions to it, etc. Uh, those all kind of represent the can represent aspects of the entity. Right, cascading delete thing. So I guess what you're talking about is in order to have like a valid order, you must have a certain number of order lines. You must have an order, like the person who purchased the order. Like you must have a various data that can construct a valid order, right? And this is kind of like the traditional thought of an aggregate. Is this what you're saying about the Lego man stored as different body parts? Because the criteria is you require these things in order to have consistency. Yeah, it's a little unclear what you're talking about to me, to be honest. Mostly I've been talking about event sourcing, so that's where my head's at. But kind of talking about commands, this is really cool too. This library supports directly middleware, so you can drop a command into a pipeline, and it'll log the command right? It'll maybe validate the command. So there's if you're asserting that this identifier is the the bank account identifier, this thing is this thing, maybe you want to have little validations that say, okay, these things exist. You may not want that. You may not need that. But it's really cool because I know that to me, a command pipeline is really there in order to be able to use the pipeline. So I want metrics, right? I want to know that how long it takes to execute a command, what type of commands are executed, how often they fail, what kind of failure reasons there are attached to them. And I want metrics for all of these things. And so the value of this command pattern, this command bus pattern, is that you can drop something. You can treat these service layer interactions with the application as like a particle, and you can drop the particle down a pipeline. And no matter what that particle is, no matter if it's command type 1 or command type 2, they all get the value. You get cheap logging of commands, cheaper metrics at this level. So you get rewards from using this pipeline. What's in the bank account aggregate? Hmm. Aggregates are at the database layer. Event sourcing is kind of at the creation of event. Aggregates are at the database layer. I don't know that I agree. So to me, the command handler generally takes your intent and applies it to the aggregate, and the aggregate makes a decision, and then you take the result of that decision and then store it. So the event store is really the database layer. Yes, the aggregate creates the state changes that get stored, but the aggregate is about making decisions, right? So if you apply the intent to the aggregate and the aggregate says, oh, based on this previous state that we already have, that intent is not valid, it will stop and it will not generate the state changes, the events that are then persisted in the event store. So the aggregate is like purely just a decision making model. So I really don't think an aggregate is a data layer concept. I think an event stream is more maybe a data layer concept that could be tied to an aggregate conceptually, but the aggregate itself is the decision making model. Aggregate root just means the top level boundary, right? The thing that you have a reference to that you interact with. It doesn't we talk about the aggregate root as being it's more like a technical implementation detail to me. The aggregate root is the class that represents that decision making model, and once you instantiate it, uh, you've seen aggregates as the folder structure. I don't really know what that means. I generally, if we're talking about project structure, I would not have an aggregate namespace or something. I don't know if that's what you're talking about. Example middleware. This is cool. So before dispatch, after failure. So these are ways in which you could like log. Uh, these are ways in which you could log different metrics. And so before dispatch and after dispatch could be used to understand and apply state to this pipeline, right? Things like what the current timestamp is, and then you can do a little bit of math after a dispatch or after a failure to see how long something took. So I think that's very cool stuff. When it comes to events, and this part is really cool too. So domain events are just structures like we've already seen. They're just structures, no problem. When we're handling a handler, these things are managed by the system. And I saw something that's so cool in here. You can tell it, I want this handler to process events from the beginning. So if you think about that, what that means is it's going to go to your event store and it will start processing events from the beginning of your event store. So if you think about like how this could be used to build a projection, that's pretty awesome. You can also say current. So you only want to start handling events that happen after you create this handler. Or you can say start at an explicit event number, which I think is like a event store, the version of the entire event store, like which event in the entire event store that you want to start at, and it will just process them one by one. I think this is pretty special. I don't think I've seen a event sourcing framework or CQRS framework that has handled this quite so simply. So if you want to have a new version or if you want to have a projection, you could launch it and just have it project from the beginning. And I think that's pretty amazing. You can subscribe to an individual event stream. I haven't ever done that, but maybe it could be useful. I'm trying to think about how you would do that. Why you would make an event listener that would subscribe to a specific stream. The way I've been using streams, I haven't been using like single streams for like a global purpose. I've been using them as like, oh, I have 20 different orders or 20 different streams. Yeah, so when I'm using command handlers, I'm definitely thinking these are mediators, these are service level mediators to interact with domain objects like aggregates, to interact with the event store, and to make this use case happen. And you can, yeah, so this is another cool thing. You can apply arbitrary metadata to your commands and your events, right? So if you decide in my application, I'm going to put metadata into these and just connect them to user identity, you can. Lot of freedom here to implement. Here's an example metadata: causation ID, correlation ID, event ID, of course, event number. The event number is like the number of events in the entire stream and up to itself. The stream version, of course, for that stream, you're looking at one event per stream per version number, right? And so this is how you do optimistic locking. Consistency guarantee. So again, we see the strong consistency, which I might call immediate consistency, or eventual consistency as an option. And this is in your event handler, which is really interesting. Strong consistency will block the command dispatch and wait for all strongly consistent event handlers to successfully process all events created by the command. That's pretty special, especially if you design your system in a very modular way and you don't end up having a lot of uh, immediate consistency requirements piling up onto a single set of operations. I agree. So strong immediate consistency. I would say eventual consistency is a feature, not a bug, right? It's not. It's not that we are wanting to avoid eventual consistency. Eventual consistency is the decoupling of time from the operation of this behavior, and so it gives us a lot of value, right? So time and space time, right, event essentially connected, and by allowing for eventual consistency, it makes it easier to scale. It makes it easier to uh, do things like have different layers of retriability or different fault models. So when you have something that's like strongly consistent in this terminology or immediately consistent and it fails, what happens, right? Like the entire thing fails. And that's not something you always want. But the fact that you can just dial in whether you want this to be immediately or eventually consistent and it's built into the framework, I find to be quite exciting. I tend to build my systems with as little immediate consistency requirement as absolutely possible. Upcasting events. So we talked about upcasting previously in previous streams, where we'll decide that we need to have a new version of an event, and it has different properties. And but when we query the events from the store, we really don't want to get like 10 different versions of the same event. We'd like to optimally just get one and operate against that. That way, when we're reconstructing state, we don't have to have the logic for a million events to reconstruct the state. So we can use an upcasting mechanism. And this system has it baked into the framework. So if we get an event in, we can apply a property first name. So apparently the event has gained a first name property where it used to be name, and they changed the name. So this upcast event, this new version of the event, now has a first name property that has the name value. Yeah, so this one is an example of upcasting where we actually have completely different event structs. So that's very cool. Like so whenever you see a line like this at the end of a function in Erlang or Elixir, that's the return value, right? So this is the outcome of this function. So we get any historical event that comes in, we are going to, and now this does this thing again where it matches and it balances both sides. It says one side is truly equivalent to the other, and then it tries to solve for that problem. And it does it by saying, okay, first of all, we know it's a historical event struct. If it's not, it errors and crashes. Second of all, we know it has an ID and a name, right? And we will capture the values within those properties into these variables. Now we can reuse those variables and return a new struct with it's the new event, and now boom, upcast. That's really exciting. Reset an event handler. That's really cool. You can make it start over from the beginning of the event store at runtime. Just start over. Very cool. Just what else does this thing do? It's nuts. Process managers. Let's see what we got. Any examples? Supervision. I don't know how familiar you may be with Erlang or Elixir and the OTP framework, but the way supervision works is you have a process that runs and it runs concurrently, and basically it follows this framework approach to to itself. So it takes in initial state, and the first time you run it, the initial state may be blank or whatever. You can determine what the initial state of a process is, and then if it you write the happy path, and if it crashes, the supervisor is watching it and it knows what the state is. And if it crashes partway through execution, it will try to recreate a new instance of that process with the last good state, and it just sort of keep it going. So it's kind of like you can think of it as what happens when you throw an exception. When you throw an exception in like PHP or Java, it will invalidate the stack frame and keep doing so until it's caught. And at that point in time, it will do some alternate behavior, right? It'll do some alternate behavior, and then you have something else come in, it'll call that method again, and it'll be fine. So when you're using the Erlang virtual machine, it's a little different because this process is running. It's this concurrent process that's identified with an identifier, kind of like how an object has a reference type. These processes have a reference type called a PID, process identifier. And what you do is you send messages to and from this process, or yeah. And if there's an error, if like you say, hey, match this side to this side to do an assignment, and it's invalid, if we expect the result of this operation to be okay, but it's not okay, it's error, then it'll crash. It'll just absolutely crash. And then you can't send a message to a crashed process and expect it to get processed again. So this is the difference in like the PHP Java kind of world versus this one, is in order to have this behavior of the system come up again, the supervisor is watching this process and rebuilding this process. Yes, it's not only configurable in Erlang, that's stuff that's hidden in C Sharp and Java, but it's stuff that C Sharp and Java can't really effectively do, partially just because the Erlang virtual machine has true memory isolation. So individual processes have zero capability of interacting with each other's memory. And if one crashes, it doesn't crash the rest of the system, and it has no risk of crashing the rest of the system, really. So what you do is you end up separating the behavioral parts of the system, your servers or your processes, from the non-functional aspects. And these non-functional aspects are like, oh, well, I need these multiple different servers working together. If one of them crashes, then how am I supposed to rebootstrap them and reconfigure them so that they run? And the idea being, if any little thing stops working, it will propagate kind of through the supervision tree. And I'm making it sound more complicated than it is. And it'll propagate through this supervision tree and then restart the parts of the system that were not working. So you think of it like as, oh, my Wi-Fi router stopped working. You turn it off and turn it back on again, and then it's okay. And so many things are like that. They have these like transient failures where in order for a system to work, you have a million different pieces that are operating together in order to create a functioning system. But if each of these pieces is able to like it, bring down the rest of the system, then it's kind of a faulty system, and it's likely to fail and it's likely to cause problems. But if these individual parts can just be shut down and rebooted and come back up with the last known good state, then you have a system itself that is more able to stay running and to get past these transient failures. This is the thing. I think this is the thing that makes me so attracted to the Erlang virtual machine, right? You have this idea of um, I'm sorry, there's really exciting music playing outside, so I don't know what kind of festival that is, but it sounds amazing. But with the Erlang virtual machine, you have this idea that you want these systems to be like highly resilient, and you can model the system with actor model such that you can bypass a lot of like common problems. And I can't help but to notice the fact that there are very few individual constructs in these languages. They're very simple, but they when they come together, you're programming them, and they are directly accounting for the kinds of challenges you have in like real production systems, to the point where like at work I'm dealing with Java, and it has like the if I were to rename a database table that like Java Spring is connected to, it like crashes. It crashes the application. But if I were to, for any reason, cause part of my application to crash in like an Erlang system or an Elixir system, that part will just be bootstrapped again, rebuilt, and it will come back up. So there's like it's so interestingly how interesting how simple some of these things become that in like Java are hugely complicated and painful. So let's see what else we got. Here's an example process manager. So I wonder what this is. So it's interested in some different types of events: money transfer requested, money withdrawn, money deposited. When it gets a requested transfer, it will withdraw the money. When the money's withdrawn, it'll deposit the money in the other account. So yeah, so this is a process manager, right? So like it reacts to things happening and makes other things happen. This is really super cool. Serialization. Another thing I noticed with this is that it has everything you need to run a cluster. So the way you scale a Java application is, generally speaking, you have some articulation point, which is like a message queue, and then you'll have uh, like message consumers, and you'll scale up the number of message consumers that are processing that queue, and you'll run more of those, and then you have to do those things in like you I don't know, Kubernetes, or you're just running more instances, and however you manage those processes. And it's a bit of a difficulty, and it's also really limited in a lot of ways. With the Erlang virtual machine, it's different because you have nodes, individual nodes that connect together to form a cluster. And across the cluster, you can address different processes just natively. Like, you don't have to marshal the code you're running. You can just communicate, and it's like almost like transparent. So you can vertically scale because these processes can be scheduled and distributed over many processors, but you can add more nodes and distribute your nodes across, or your processes across nodes to horizontally scale. But you still have this context of your within your own the same system. So like the normal bounds that I think about when I'm building like a Java application is the system is like this big thing with Redis, with um, different many different instances of the application running or whatever all together to be the system. But with like an Erlang or an Elixir system, so much more of it's running within the virtual machine. You can get away with running using inside the application structures for caching and stuff like this, such that you don't rely on as many external things. So it brings down the infrastructure complexity quite a bit. Uh, Dota says refactoring database tables is messy. It's scary enough we just don't attempt it. Yeah, it's actually really ridiculous, actually, how bad it can be. So whenever you deploy, if you're deploying using multiple replicas of an application such that your application doesn't go down during deployment, you basically have multiple different versions of the application running at the same time. And so in order to migrate different types of various things in these applications, you have to have an interstitial state that is valid for both or of these versions of the application at once, and then you have another deployment that cleans up the old one. And everything is difficult. Everything is made so much more difficult in this model, right? To the point where if you want to rename a database table, um, you really have to do things like create triggers and keep these multiple tables up together, and then deploy a new version of the application, and then deploy another one after that that cleans up the old stuff. And it's just extremely complicated. And whenever we get into a situation where we can't do basic stuff like rename a table, that really bothers me, and I just want to smash my face against the problem until we get a dedicated pattern to resolve it, so that we aren't like stuck not knowing how to do this ever again. Really cool stuff. I'm really impressed by this. Let's look at the event store, because I think it's really cool. They build the event store using the power of the underlying construct. So in this example, they're using the event store with Postgres. And the way they do things like rebuilding projections, or having durable subscriptions to process managers for event changes, the way that they do this stuff is they actually leverage the data layer a lot, which I find to be just fascinating. You can write to a stream, right? Core behavior. So you'll have event type. I probably wouldn't tie my event type. This always kind of bothers me, like the idea of having classes in the database. I wouldn't want classes in my database and to be expecting to do this, because now changing the code is going to be really difficult. So I'd always like some kind of way of mapping the structure to an event type uh, specifier, a name, so that I can uh, not have to deal with the fact that all of this has to be refactored, or if I do a code change, like a simple refactoring, it breaks everything. Now, can you tell me, do you hear a bunch of background noise from my microphone? Because right now, I don't know if there's a football game, or I don't know if there's what's going on, but it is crazy out there. It's pretty crazy, right? Sorry about that. I don't know what to do about it. I can't go outside and shut them down, but not a personally a huge fan of the sports stuff. Okay, cool. Um, so here you can see you start with a UUID of the, yes, no class names in the database, 100%. So here we have the event store, and I guess we start with a stream ID, and we get the stream, and then we list it, right? And then we can tell how many events are in the stream. So this is like a, hey, give me all of the events from the stream with this ID. The big thing for me is don't map database tables to coding classes. Right. So you're talking about database tables to classes is like active record, right? You didn't mean it as a Ruby comment. Okay. Well, it was not clear to me. Okay, cool. Check this out though. When you're say appending events to a stream, you can say, "Hey, I don't care. Uh, allow any stream version, including no stream." Right? Or when I write these events, I want there to not already be an instance, instances of any events in the stream. So let's say you're creating a new event stream. You're registering a request for an authentication, or you're registering a new order, you're placing a new order. You might tell it, oh, when you're storing this, expect no stream, and that way it won't like add your new stream order was requested or order was replaced to an already existing stream. But the cool thing is this is how they're implementing optimistic locking, right? So I expect that the version of these events that I'm putting in match up with what we already have in the store. Otherwise, there's a problem, and we had some kind of concurrency hit, race condition, basically. Yeah, so I'm the same way, Dota. It doesn't matter to me how something is stored. It matters to me how it's like generally how it's represented in the code, and then when it hits the data layer, whether like so if you have a repository, it can take this code and figure out how to serialize it according to the technical requirements of the serialization mechanism. So if I'm pulling it apart and I'm storing it in a bunch of database tables, who cares? Isolate it at this layer, keep that complexity from ever becoming a problem anywhere else. And when I reconstitute or when I store those objects away, I don't have to think about it because it's on the other side of the interface. Reading from all streams, very cool. Stream from all streams. So here's this is funny. Um, Stream all forward. So this is going to create a stream of all of the events, but then it's going to create an enum. And in Elixir, enums are about returning a fully enumerated list. So you're not operating on streams, right? So this is going to block and fill memory until okay, hold on. Actually, this actually says this right here. This will read all events into memory. It is for illustration only. Use stream functions. So this is super cool. You can stream all events from the event store and operate on them in chunks using with back pressure, using the stream functions in Elixir. And you don't have to do your own manual writing of things like query the first 1,000 events, then query the second 1,000 events, paging through them or cursoring through them. You can build it with the system in like this really simple way. Event linking allows you to include events in multiple streams, such as copying an event from one stream to another, but only a reference to the original event is stored. Now I can see why you would do something like that. But what I usually do is I'll have multiple event streams and they will reflect on the same event with slightly different perspectives. But I think that having this capability only like increases the tools you have to choose from. So maybe if I had these tools in my systems, I might have leveraged them. But it's really cool to have this capability here. Subscriptions, transient and persistent subscriptions. Interesting. So a transient subscription where new events are broadcast to subscribers immediately after they've been appended to storage, or persistent subscriptions at least once delivery. All right, so this is the like the holy grail, right? At least once delivery. That means it's not going to miss delivering an event to a subscription. It's going to maybe deliver it more than once, but it doesn't matter because you know you got it. So this is for really important critical processes. So if you're processing financial transactions, you can guarantee that um, there's a cost involved to doing this, right? But you can guarantee nonetheless that you're going to be able to react to that event, and you're not going to leave like half of the financial transaction hanging. Yeah, I'm not sure about the event linking. I would have to think on it, and maybe other people have experience where they would do something like that. I don't understand exactly how I would use it. It could be useful for creating. That's a good point. So if you wanted to take multiple streams together and create a new stream, that could be true. What if also you wanted to re-project a stream, like you wanted to expire an old event stream and generate a new one because you're refactoring how your aggregates work or something, maybe. Yeah, it's unclear to me, but I think that maybe it offers some capability to do refactoring, and anything that lets me refactor or change the system makes it less rigid might be a good thing. So it's very clear to me that these transient subscriptions are really about, yeah, you get the event and you react to it, but if you crash in the middle of reacting to it, maybe you're not going to get that event again. So maybe you could use it for something like logging that's less critical often. You know, you often don't care if you're missing one log entry here or there. Versus like critical business processes, in which case you might want to use like a persistent subscription. And it's cool because it looks like you can change these things at runtime. So you can build systems that maybe generate new, uh, like, I don't know, new event handlers, and then you can set them up to subscribe or unsubscribe at runtime. This is pretty cool. You can filter which events you get from the event store. So I guess this is like a optimization. If you know that your projection only takes 20 events or 4 events out of an event stream, then you can limit those and it probably gets performance improvements, I have to assume. Really cool stuff. And again, I'm just so pumped about this idea of starting from the origin. The idea of just being able to create a new projection, for example, and saying go, and you launch it and it just starts building itself. That's crazy. Not having to have another system in place that does it for you. The framework just handles it. I love it. Subscribe to all streams, and then you know the standard receive block that's in Erlang and Elixir that lets you receive messages to a process. And yeah, runtime unsubscribe. That's fun. Wonder how you can ban someone. I'll have to figure that out someday. Here's an icon. Ban. Ban's a good one. Like that. Cool. Event filtering again, mapping events, subscription concurrency. A single persistent subscription can support multiple subscribers. Okay. Events will be distributed to subscribers evenly using round robin. The competing consumer pattern enables multiple subscribers to process events concurrently. Right. So this is something like I think that we all deal with a long time ago, or not a long time ago. We all deal with all the time, right? Where I need to have like 5 message consumers running against a single subscription. Like maybe I'm using Google Pub Sub or Kafka with consumer groups or something like this. And so what happens is you will have ordered events in the queue. They're absolutely perfectly ordered. The order was placed, the order was paid, the order was shipped, right? All in order. But then you have like 3 message consumers, and they all pick up a message, And now they're processing those 3 events at the same time, and you have no real reason to believe that they're going to be processed in order, right? They might be processed very much out of order. So how do we handle this here? By default, a subscription will only allow a single subscriber. So a single subscriber means every message is processed one by one, which is the easiest way to handle concurrency, right? You don't end up with processing messages out of order. But this framework supports having multiple consumers on a single queue. Concurrency limit, the number of subscribers allowed to connect to the subscription. Limits how many in-flight events will be sent to the subscriber process before acknowledgement. Okay, so yeah, so if you this is a way of kind of, I think, applying some back pressure actually. Partition by is an optional function used to partition events to subscribers. It can be used to guarantee processing order when multiple subscribers have subscribed to a single subscription. As an example, to guarantee events for a single stream are processed serially, but different streams are processed concurrently. Can you imagine this? Can you imagine just being able to say, partition the instances of this subscription by, I don't know, user ID or something like that? Can you imagine that? And then you don't have to build a system that guarantees the messages can be processed out of order. You just kind of have that capability built in. Like, imagine how much simpler that makes this code. We have so much complexity in what we're building because we want to be able to handle duplicate messages. So we have certain item potency on the message level, and we want to be able to handle messages out of order. So we expect to be able to sometimes get the second message in a stream before the first one, and our logic has to be able to support that. And that now all of a sudden, we can just choose to partition by some arbitrary property, and we don't have to code those things. We just get it baked into the system because the framework supports it. Crazy to me. With multiple subscriber processes connected to a single subscription, the ordering of processing is no longer guaranteed since events may be processed in differing amounts of times. Of course, that's true. This can cause problems if your event handling code expects events to be processed in the order they were originally appended. Yes, so generally speaking, if you're running multiple instances, you have to be able to handle them out of order in some way. You can use partition by to guarantee ordering of events within a particular group, like an event stream, which is pretty much the correct partition most of the time. Crazy. So partition by example. So by stream, recorded event, stream ID, subscribe to stream, partition by stream. So okay. So this is the function. This function is saying take in the events and return the property that you should partition by, and you pass that function, and then that function is applied during the routing, basically the routing and distribution of the events. An example subscriber. So here's a gen server. This is the Erlang OTP framework, the concurrency framework. That one of the parts of Erlang that's so special, frankly. And you have things like start link, which this is all like a framework. This is like this is baked into, like, this is an expectation baked into the framework where you have this start link here, and this is the entry point for starting this process from the supervisor. Then this is a function you call received events on this process, on this module. Subscriber received events with the subscriber, and it will call your server. So this module is a collection of functions, but this module will also be used to create a process using the OTP framework, using the gen server model. So when we first initiate the process, we subscribe to all streams. And then whenever we're successfully subscribed to all streams. Okay, handle info subscribed. Okay. So when we get events in, let's get from the current state the existing events in the subscription. confirm receipt of received events, and then we're going to update the state with the events. So, okay, so what this process is doing is it just has a list of events, and every time it receives them, it appends the ones it received to that list. And then you can send the message, hey, give me the received events, and it will reply to whomever sent that message with the current events in the state. So this is saying, this is the state, pull apart the events from that state map, which is like a left to right dictionary, right? And it'll return those events. So all this is doing is collecting events from the subscription and then giving you them back if you ask for them. Very cool. Running on a cluster, used in production, benchmarking performance. Very cool. What else do we have? So ecto projections. Ecto projections are a way to project your data to relational database using the ecto library. So the ecto library is like, it's like kind of like an ORM, but it's functional, not object oriented. And what you do is you specify a schema, and it's going to allow you to validate data and then persist it into the database using a repository. And I think using ecto for projections is probably a pretty good way to have a relational database backing for your projections. Example projector. So project this event. So notice, like, okay, so really quick, just side quest. This project, this doesn't exist in the Elixir language. This is a keyword, but it doesn't exist in the language. What's happening is there is, within this commanded projections echo module, there's a macro definition for adding this project structure into the language. So the cool thing about Elixir is that it's actually a really small programming language, but you can use its meta programming system in order to add behaviors and add features to the language. As a matter of fact, a lot of Elixir is built using its macro system. So when you define a module with def module, this is a macro. This is not like inherent in the base level of the language. It's added to the language with its own meta programming system, which is really exciting to me, because you can do things like this. You can define your own DSLs for things like projectors. Say, okay, I'm going to project this event, and this is how I'm going to do it. I'm going to pull the name out of the event, like maybe it's a person's first name. Then I'm going to make a database record, like a struct that will go into the relational database with that name, and then I'm going to insert it into the database. So this is what it takes basically to create a relational projection that can be queried, but it's tied to this underlying relational database. Recipes. This is pretty cool. I think that a lot of projects could use something like this. So they have a bunch of issues, and they're like, hey, I want to, for example, use different event types. Because you saw me complain about having the module, the struct name in the database, right? But I want to use account closed instead of that struct name. And they said, oh yeah, no problem. Just create your own type provider, and here's how you do it, right? And you can replace those. How do I manage test process managers? Well, here's how you do it without having to deal with any IO, right? Anyway, like I'm gonna stop going through this now, but this to me is really exciting. I'm gonna altogether 100% stop even building my own framework in Elixir and just jump on this and start building something with this. And I got plenty of other problems that I can solve on my own, right? But with something like this, something that's so closely tied to my own values, and something that's so featureful and mature. I have no need to reinvent this specific wheel. I'm definitely gonna maybe in coming streams sometime we'll build some event sourcing stuff using this library. I got to get a little bit more familiar with it. My elixir is good enough to build stuff, but not good enough to be like super fast. Sometimes I have to like reference stuff or whatever. Um, anyway, that's something that I found last night, and I honestly it kind of kept me up thinking about how cool it was, and I should be careful about looking into these projects late at night.